GCF, what would be the greatest common factor of this 8g squared plus 80g plus 72? Landon? 8. Okay, so if I factor an 8 out, I have g squared plus 10g plus 9. All right, so we should be able to get to a point now where we can factor this. So if I were to factor simply what was in the parentheses, I'm going to draw my x. What am I going to put at the top of my x? What's going to go at the top, Blake? And what's going to go at the bottom, Blake? What are my two numbers? 9 and 1. So now this 8, do not forget about the 8. It comes along, but now I have g plus 9 and g plus 1. So this would be complete factored form. All right, so the 8 comes along, we factor the 8 out, g plus 9, g plus 1. This is your first step when looking at factoring, especially now when we get to where a is not equal to 1. Your first instinct should be, can I factor out a GCF? Sometimes you can, sometimes you can't. Okay? Especially as the numbers get bigger and bigger and bigger, definitely look to factor out a GCF because it's going to make it a lot easier. Because if you can get the parentheses piece to have a being 1, then it's real quick. All right? So star that in your notes, box that in your notes, whatever you need to do to remember, factor out a GCF or look to factor out a GCF first. All right, as soon as you get any quadratic where a is not 1, see if you can pull a GCF out. It'll make things a lot easier for you. And that's the most overlooked piece that students forget. And the problem is a lot harder because they didn't do that to begin with. Okay, so whatever you got to do to make yourself remember that should be your first thought. If you see a is not equaling 1, can I bring out a GCF? And sometimes you can, sometimes you can't. Okay, but when you can, it makes the problem a lot easier. Let's do a couple other just kind of abstract ones. We'll do these together. If I had the quadratic x squared plus 10x plus 24, and it was rewritten in the form of a product of two binomials where it's x plus 4 and x plus k, where k is a constant. So k is just going to be some number, and I want to figure out the value of k. All right, so they're telling me that I have a quadratic x squared plus 10x plus 24, and I want it factored into a product of two binomials. I know one binomial is going to be x plus 4. The other one is going to be x plus k, where I don't know what number k represents, but I need to figure it out. So first off, we want to factor this. If I were to factor x squared plus 10x plus 24, I'm going to have 24 in the top, 10 in the bottom. What are two numbers I multiply to get 24 that have to be 10? Eva? 6 and 4. So then I know it's going to be x plus 6 and x plus 4. Well, I already know that x plus 4 is 1. So this 6 is k. So k is equal to 6. So for this type of problem, they told me it's going to be two binomials, and I got to figure out what k is. Well, in order to do that, let's just do the entire problem. Let's factor it into two binomials, and that will tell me the answer. Okay. Number 2, the expression 2x squared plus ax is equivalent to x times 2x plus 7 for some constant a. So again, we're trying to figure out what a is. A is going to be a number. We got to figure out what a is. What is the value of a? So we had a quadratic, 2x squared plus ax, and they rewrote it as x times 2x plus 7. So what did they do on that? So they factored an x out, okay? So to get from here to here, they factored out x. So they wrote this as x times 2x. So what is a going to be? So in this case, a had to be 7 because they factored out an x. And so the only thing I could have put in there would be 7. So originally, this quadratic should have been 2x squared plus 7x. So a had to be 7. So these two problems are from a practice SAT. So these are SAT type questions where it's stuff we know how to do, but they're just manipulating the problem a little bit differently to be able to get to the answer. Okay, all right, so let's actually get into factoring if our a is not 1 and we cannot factor out a greatest common factor. The process is pretty much the same, but there is an extra step in there, and you got to be very careful. And I'm going to point out a common mistake that always happens that I do not want you to make this common mistake. All right, so if we were to factor 2x squared plus 11x plus 12, same thing, we're going to make our cross. All right, look for a greatest common factor, make the cross. Is there a greatest common factor in this one? So I have 2, 11, and 12. No, 1 is the only number that's the same in all of them. Okay, so I don't have a greatest common factor I can factor out. So what am I going to put in the top of my cross? Abby? 24. Because remember, this is a times c, and so this becomes 24. So now when a is not 1, we have to look at a and multiply it by c to get 24. Still adds up to be 11. So two numbers that multiply to get 24 that add up to be 11. Landon, what do you say? 8 and 3. Okay, so now I can write 8 and 3. So here's where it's different. Okay, when a is not 1, we cannot make the jump and put in our numbers 8 and 3. This 8 and 3 is really breaking up this 11x. So I'm going to say instead of 11x, I'm going to say plus 8x and plus 3x because both of them are positive. 2x comes down and the 12 comes down. Really, all I've done was break apart my 11x. But it has to be specifically those numbers, 8x and 3x. Now I can do it by grouping. So I'm going to group my first two, and I'm going to group my second two. Now I want to factor out GCFs from each of these. 2x squared plus 8x. What is my GCF of 2x squared plus 8x? First off, look at the numbers. What's the biggest number I could factor out? 2. Can I factor an x or an x squared or anything out? Yeah, I could factor out 2x. And again, we're just trying to rebuild this. So 2x times what gives me x squared? Well, that would just be x. 2x times what gives me 8x? That would be 4. These are all equivalent to each other. We're just writing them in a different form. So 2x times the quantity x plus 4. Now I want to look at this one. I want to come up with another one. 3x plus 12. Well, 3x plus 12, these parentheses have to be the same. So this is going to be x plus 4 and x plus 4. They have to be the same. So now I'm kind of working backwards. Okay, x times what will get me 3x? Well, that would be 3. And then I can do a quick check. 3 times 4, yep, that does equal 12. So I'm good. So now I have 2x times x plus 4 plus 3 times x plus 4. X plus 4 is a common factor in both of these. Okay, both of them have x plus 4. Well, in the first one, it's going to be x plus 4 times 2x. In the second one, it's x plus 4 times 3. so I can create my other binomial from that. Okay, so what I have in my parentheses, I write that as a common factor. My second binomial is filled in with the GCFs of each one. All right, and we can check this. If I were to FOIL all this out, so I go x times 2x, that's 2x squared, x times 3, that would be 3x, 4 times 2x is 8x, 4 times 3 is 12. I can combine these together, so I have 2x squared plus 11x plus 12, and that checks out with everything that I started with. All right, so this is that extra step. I said pretty much the same, but be careful. Okay, we're still gonna make our cross, a times c on the top, the sum on the bottom. But what those numbers now do is they split up our b term in our quadratic. Blake. Okay, so from right here, so x plus 4 is a common factor. Okay, it's in both of them, and so that's why I wrote x plus 4 as the common. I don't like that color. Let's go red. Okay, so x plus 4 is a multiple in each one. Okay, so I took x plus 4 and it's being multiplied by 2x. So now this is equivalent. I've just essentially written it on the other side. But then on this other one here, I have x plus 4 times 3. So this is saying x plus 4 times 2x and x plus 4 times a positive 3. Okay, so I'm treating that all as one. X plus 4 is one thing. I have to multiply it by 2x, and I have to multiply it by 3. So it's an equivalent form. Okay, all these work, but that's how you go from after you factor out your greatest common factor to your final binomial form. All right, so our final answer would be here in this blue and red box now. X plus 4 times 2x plus 3. We're no longer just x plus 3, x plus 4, or anything like that. Now we have some coefficients on x, some numbers in front of it, because our original problem, a was not 1. All right, and the 2 doesn't correlate. It's not because a was 2 that we have the 2x at the bottom. That has nothing to do with it. This is how this one worked out. All right, let's do another one for practice. So 4x squared minus 4x minus 3. What is going to go in the top of the cross? No, what do you say? Negative 12. What's going to go in the bottom? Negative 4. Okay, it's a negative value that's our product in the top, negative 12. So I know one of these has to be positive and one of these has to be negative. Okay, or one of them has to be negative and the other one positive. Doesn't matter, either way. So I'm trying to think of two numbers, multiply to get negative 12, but add up to be a negative 4. Eli T, can you think of those two numbers? Okay, negative 6, positive 2, exactly. All right, it can't be a negative 2 and a positive 6 because that would get you a positive 4. It's got to satisfy both. Multiply to get negative 12, add up to be a negative 4. All right, so now I'm just going to rewrite this. So 4x squared just comes along. We don't do anything with that. But we broke up the negative 4x. So negative 4x now becomes a positive 2x and a negative 6x. And then we still have this minus 3 going on. I'm going to group these, and I'm going to group this negative with my groupings. Yeah. Nope, nope, it'll still work out. Okay, but I did something here where I took my grouping and I included that negative value. And so I'm thinking of adding these together. Okay, so this is plus a negative 6x plus negative 3. It hasn't changed anything, but I'm still grouping these together. All right, this one I can factor out. So again, I want to factor out the GCF. So when I do that, I can factor out 2x, and this becomes 2x again plus 1. Now my second set of parentheses has to be the same thing. Okay, those have to be the same. So now I'm kind of working backwards. Okay, 2x times what will give me a negative 6x. 2x times what will get a negative 6x? Negative 3. And then we can do a check. Negative 3 times 1. Yep, that does give me my negative 3, which is what I want. So now my common factor is 2x plus 1. And I'm going to take that as an entire group. That whole thing is going to be multiplied by 2x. But then that whole group is also going to be multiplied by a negative 3. So 2x plus 1, 2x minus 3. Feeling all right on this stuff? Okay, just take it step by step. Okay, don't rush it. This idea of breaking up that negative 4x is important. Once you break it up, then you have a little more work to do. Do not immediately jump and say, well, this is x plus 2, x minus 6. That does not work when a is not 1. Sam? Or up here? Okay. So the negative 12 and negative 4. Okay. So I'm trying to come up with two numbers that when I multiply, I get negative 12. But when I add them, I get negative 4. Okay. So multiply to get negative 12, add to be negative 4. And now those values simply break up our b term. So we're going to break up our b term, and we're going to continue on. Okay. Good question, though. Owen. Nope. Nope. You'll get a common factor that's a little bit different. So let's actually do that real quick, because that's what two of you now have asked that question. So let's actually show this. So if I did it as 4x squared minus 6x plus 2x minus 3. So I chose negative 6 and then a positive 2. Just change the order up. All right, I'm still going to do my grouping, but this is already addition between the 6x and the 2x, so I'm just going to do it like that. So now this one, I could factor out 2x again, and so this is 2x minus 3, and then I already have this 2x minus 3 over here, so here's something, really there's a 1 that's factored out. Even though it's not written, there is a 1, and we're adding these together. So 2x minus 3 is my common factor. My other piece I would fill in would be 2x plus 1. Okay, so these are the same final answers. In multiplication, it doesn't matter the order. 5 times 2 is the same as 2 times 5. Okay, so you can do it either way. Doesn't matter. All right, let's do another one. Once you're getting started, see what you can come up with for a final answer on this one. Okay, so this one, two numbers that multiply to be 25, that add up to be 11. 10, yep, I wrote 10. I don't know why I said 11. And so this is 5 and 5. This one, our a value was 1, so we can immediately jump to say x plus 5, x plus 5. we can write this as x plus 5 squared. And that's what I'd like to see as a final answer. Okay, rather than writing x plus 5 times x plus 5, it's simply x plus 5 squared. So if you had x times x, that's x squared. Y times y is y squared. X plus 5 times x plus 5 is x plus 5 squared. Okay, just a couple more things. Special case, if we have a difference of squares. So we saw an example of the difference of squares in the lesson check, where we had it as x squared minus 64. So again, difference means subtraction. A difference of squares is two things that are squares that are being subtracted. 64 is a square because that's 8 squared. Okay? 81 is a square because that's 9 squared. Okay, so we need to know perfect squares, and we want to do the difference of squares. If they ask us to factor a problem, and we recognize that it is a difference of squares, in this form of something squared minus something squared, it has to be in this form. Okay, each term is a square, and we're subtracting those. If you see this difference of squares, you can always factor it to be a plus b times a minus b. It'll factor into this form every single time. All right, and we did this one, x squared minus 64, because this was a negative 64 that adds up to be 0. This was a positive 8 and a negative 8, and so we wrote this as x plus 8, x minus 8. So if you don't remember this property with difference of squares, you're fine. You can still do the cross method. You'll still get to the right answer. This provides a little efficiency. If you recognize something right away is a difference of squares, you can simply jump right ahead and say, well, it's going to be a plus b, a minus b, every single time. Okay. And again, I just have on here. If you can remember this, it will save you a step, but you can always do that cross method to solve any quadratic. Eva. No, because then it's not a. So if you had like 4x squared, so that's a good question. You can do it. I don't know if we'll get into it, but you could have like 4x squared minus 81. And so if we essentially square root each piece to recognize that it is a square, this would be 2x plus 9, 2x minus 9. So yes, you can do it. I don't think we'll get into those, but no, that's good extension piece for it. So we could have it to look something like that. Okay, so x squared minus 36. X squared minus 36. What's this going to be? Eli. Done. Okay, like I said, this provides efficiency because you know it's going to be x plus 6, x minus 6. If you want to do it with a cross method, that's fine. You'll still get the right answer. I mean, it might take you 10 seconds longer. Okay, it's not a huge savings, but if you recognize this right away, you can jump to say x plus 6, x minus 6, and you're done. Okay, that is factored. What about if I asked you to factor x minus 9 as a difference of squares? Just like we were doing a second ago where we did 4x squared minus 81. What do you think, Blake? Okay. So in this form, x doesn't look like a square, okay, because it doesn't have the squared on it. Okay, but remember how we did that 4x squared minus 80, or 4x squared minus 81. If I take the square root of each of these, I can write this as square root of x and square root of x. Because if I take square root of x times square root of x, that is x, if I multiply those two together. And then square root of 9 would be plus 3 minus 3. Okay, so if you were ever given one that's just something x minus 9, you recognize that the number is a perfect square, but you only have an x or a z or a t or something like that, you can treat that just as square root of that value, and it will work. So this one is square root of x plus 3, square root of x minus 3. So this one's just a little bit different. Okay, all right, so your assignments. We're going to work through these problems, 221 in the textbook, and then there's one IXL. So Algebra 2 tab, make sure you're going into the Algebra 2 tab. Algebra 2 tab, factoring quadratics, get to a score of 80.